Scalars versus vectors, understanding physical quantities with and without direction. In physics, we measure many different properties of objects and systems, but not all measurements are the same. Some need only a number and a unit, while others require additional information about direction. This fundamental distinction is what we'll explore today. Before we dive into scalars and vectors, let's understand what physical quantities are. Physical quantities are measurable properties of objects and systems that can be expressed with numerical values and units. For example, when we say an object has a mass of 50 kilograms or a temperature of 25 degrees Celsius, we're describing physical quantities. Every measurement in physics involves a number and an appropriate unit. Let's start with scalar quantities. Scalars have magnitude only, which means they tell us how much of something there is, but not which way it points or moves. Think of scalars as simple measurements that need only a number and a unit to be completely described. Common examples include mass, temperature, speed, and energy. When you say the temperature is 30 degrees or an object has a mass of 10 kilograms, you're describing scalar quantities. Here are some concrete examples of scalar quantities. Mass, 50 kilograms tells us how much matter an object contains. Temperature, 25 degrees Celsius describes how hot or cold something is. Time, 10 seconds measures duration. Energy, 500 joules quantifies the capacity to do work. Notice that each of these measurements is complete with just a magnitude and a unit. There's no need to specify a direction. Now let's examine vector quantities. Vectors have both magnitude and direction. They tell us not only how much, but also which way. This additional directional information is crucial in many physics problems. Common vector quantities include displacement, velocity, force, and acceleration. For instance, saying a car moves at 30 meters per second isn't complete without knowing which direction it's traveling. Let's look at specific examples of vector quantities. Displacement. 50 meters east tells us both the distance and the direction of movement. Velocity, 30 meters per second north specifies both speed and direction of motion. Force, 100 newtons downward describes both the strength and direction of a push or pull. Acceleration, 9.8 meters per second squared downward indicates both the rate of velocity change and its direction. Each example requires both magnitude and direction to be fully described. One of the most important distinctions in physics is between speed and velocity. Speed is a scalar quantity with magnitude only. When we say a car travels at 60 kilometers per hour, we're describing its speed. Velocity, however, is a vector quantity with both magnitude and direction. Saying the car travels at 60 kilometers per hour north describes its velocity. Two cars moving at 60 kilometers per hour have the same speed, but if they're moving in different directions, they have different velocities. Let's summarize the key takeaways. First, scalars need only magnitude to be fully described. A single number with a unit is sufficient. Second, vectors require both magnitude and direction. Without direction, the description is incomplete. Finally, direction makes all the difference in physics problems. Whether you're analyzing motion, forces, or energy transfer, knowing whether you're working with scalars or vectors is essential for solving problems correctly. Understanding this distinction is foundational to success in physics.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.